actually little constructs that do two things. They have some abstraction over time and the ability to extract a value.
Is he trying to give me a monad right now? Has this turned into, I would like to introduce you to your Lord and Savior monad?
Nope, nope. This is about having a construct that is basically a state management construct where you can have immutable data sort of inside this box, and this box is basically your machine. So you basically say that, all my program by default, everything is pure functions. So if you know a little bit of programming, I think that the appeal of having simple data going into pure functions and then making data transformations, that this is kind of like the simplest thing. I think this is kind of an obvious appeal, right? And in order to not have this state transformation everywhere that makes this thing basically a machine, you have the machine in a small place. And you say that here I need a machine because I have a game loop and the state moves forward.
That's really important because that's your path back to some.
And you say deref, and deref gives you an immutable value. So that basically you can always look at the snapshots of what the state was at one point in time. You can have a snapshot, and basically the value is your ticket back into the pure world, because now I have a value and I can make data transformations on that value without the rest of the program being a machine and moving forward in time.
Simplicity. Right? If I have a way to get out of this thing and get a value out, I can continue with my program.
I would love like a more concrete understanding of what this means. Because this is one of those things where you learn or see problems from new angles, and it makes it a lot more clear. What does this mean?
Okay, so there's the philosophical part of it. That is the talk called the Are We There Yet? Are We There Yet? This talk is one of the most interesting philosophical talks of software engineering, in my opinion, talking about the philosophy of how you can represent time in a program. And in particular, this means that if you have registers and the registers change because the software moves forward, then you have no ability to have a model of time, because when you look at a piece of data, then how do you know that this register is not just changing? You need some software construct. So you need, for example, a construct that is something like a block universe or something like that, because this is a construct where time is allowed to emerge from, right? You need the right kinds of abstraction in order to model time. And if you have a block universe, for example, that means that in a block universe there's no actual flow of time or anything like that, but all the snapshots just exist. And if I keep around these snapshots, basically, then I have a model of time, because I can, for example, give timestamps to all of the snapshots, and now somebody could come to the system and ask sort of what is the evolution of this state. This also kind of shows that state and change and time, these things are sort of related in this way. And I guess in the theoretical physics that sees time as an emergent property, I think they all basically go sort of into something like these snapshots. I sort of assume that, but yeah, not entirely sure about that. Okay, so here I have some random website that I made once. This is still up, of course. This just makes like random shapes in a browser with a button. I don't know what this is. This is just it's like sort of a beginner style website that I wanted to show somebody how to write Clojure script. So you click here and it makes a random new state. So the user here has this interface to move the state forward, and this thing is then in a new time evolution, right, after this state transition, and the history is being kept around. Yeah. So this basically you can see this as an implementation of a block universe if you want to, in a way. Now basically I have a time line of 3 states, 1, 2, and 3, and basically they are. I have a redo button. I basically have history and redo and undo implemented in this project. So yeah, if you know software and front end and so forth, then let me clone this repo and look at the code and kind of like see the place where we use one of these Clojure refs, because I don't remember, but I'm pretty sure that there's an atom in this project. So this is Lyrios, I think. It's some flower name in Spanish. BB Dev. Okay, this would be kind of fun if this just works. Serving assets. Okay. Oh, okay. This is the web page. That's kind of funny, man. This. What does the README say? Visit this dev server. So then say cider connect. Okay. Cider connect Clojure one on localhost 1339. Okay. I'm connected. I'm connected to the browser. So if I say here alert, I get a JavaScript alert. Okay. This is kind of basically the dev environment of this project now. Here is the code. This is just some Clojure code. It's a lot. It's big because it's UI, right? And yeah, so here is some code. This button, for example, let me see. I comment out this button for a sec. I need to reload here. Okay. So this is this left click button. And you see here that it swaps this state. It calls swap on state. So now there is this state atom, and of course now I also have the power to say deref on this state atom. This is this ref type, right? The ref type that Richiki was mentioning in the talk. And basically, when I call deref, I get the current state. And of course, I just put all of the state of the program into this atom, and that works by this. Apparently, it simply has this vector here that is this history, and then a cursor, and that's it. That's it. I can also, of course, I can take the state and then I can say keys, and I can explore. There's only one key, so I can say add, and then I can say cursor, and I can sort of look at the current value that is 0. Now, if I generate a few, then I look at the cursor and it's 4. And if I go back here or something like that, 0 again. So basically, what I can also do is that I take this state, and now I print it. and this is sort of like this is the data notation called EDN that is like sort of similar to JSON. Comes from the same root of Lisp S expression as where JSON also comes from. So there's sort of this relationship there. I could take this data structure and put it onto my disk. Oops, not called JSON. art.edn. And now what I could do is I mean it's kind of it's obvious, of course I can do this. But I can reload this page and the state is reset and thrown away, forever gone. I need to drop a file into the browser. One sec. For example, input type file load content. Okay, let me instead of this click counter do this. So I would need to also add another button called export state. Okay, so let's say I generate some art, then I look at the state. I say export state, it outputs a file, then I reload the page and my state is gone. And now I can recover this universe by going to here. Drag and drop not implemented. Or is drag and drop not implemented, actually? Ah, it's implemented. Okay. And oh, wait, something didn't work. Is there an error? No. What? There was just nothing. Okay, then reload and do it again. Ah, yeah. Okay, so now I recovered the art from earlier. So this is kind of the power of immutable data and sort of like plain data. It's like kind of, yeah, sort of obvious thing once you sort of start doing it. And I mean, you also know like the internet runs basically on JSON. Like there's a sort of a reason for that. And this comes from Lisp. This is kind of like this kind of idea that data is sort of central or something. This is kind of randomly a little bit sort of a Lisp thing. So yeah, and now the power of what this means with the time and so forth. This is that basically there's this state atom that I implement that here, or I define it here once. It's like this is kind of like, this is a reagent atom, so basically this makes a React context to update, but this is kind of like a second thing that has to do with this browser front end here. But this construct is the same as in the Clojure core called atom. This basically returns an object. This is a Clojure construct that does all the setters and getters in your program. Yeah, you can say def an atom, and then you have the function called swap, and that basically makes a new state. And let's say that I say update inc, and then the state would move forward in time. This is sort of the only place where state is being transitioned in Clojure, and everything else is made from pure functions and these immutable data structures. So basically everything is data transformations, and then there's like these tiny places. In this whole application, I have one state atom and nothing else. And then there's, for example, this function called current art, and I can also call this function, and this is where sort of the obvious beauty of the stuff is apparent. Like so the program is going. The state is basically being updated. If I ask for the cursor, this goes up and up and up. But I can always say dref, and then, for example, call my pure function on it. And this is kind of the beauty of immutable data structures and time constructs. Program could be running forward in time now, right? I could oh wait 1 sec. Make a new art every 2 seconds. Okay, let me quickly write the JavaScript that is doing that. So set. Oh my god, nice. This probably would just work. Okay, so I'm gonna do this when I reload the page. I'm gonna also load this this set interval JavaScript function. Okay, so yeah, okay, takes a little bit, but yeah. Okay, so now I have basically a program that has its own evolution because something is happening. It's like in the real world. Like a program just doesn't sit there. Like a program moves because it has interactions with the world and sort of, yeah, you can't get rid of the world, kind of. So, yeah. But now I'm basically here connected, and I can say that I say deref to the state. And I can say that is my def state at time 0, for example, or time 1. And I can def that state, put it into a variable, and this variable is now pointing to an immutable data structure. So if here I say give me here the count of the history, yeah, then it's 23 because this is something in the past. And this is the thing, like I have an implementation of time because I am able to talk about the past, for example. Like this is a coherent concept, I guess. But yeah, and also importantly, I have the program goes forward, and I always have the chance to look at the snapshot of the program. And let's say I have a complicated function that, but yeah, I mean, this, for example, is a good example. If I export this to a file or something like that, how do I know that while I look at the values that they don't change? How do you know that? You in Java and C++, you need to lock this object, and when you lock the object, you are prohibiting all the writers to keep on doing their work. This is yeah, and even worse, you're also prohibiting the readers. So yeah, this is basically sort of like making lockless programming possible. And then yeah, I have history is very easy. So let me show you how the histories let me show you how the history is implemented. Here's the button that goes here to the left, and that says update update in the art, the cursor, and then -1. And so yeah, because I keep around the history, that works. This thing. What button is that? So this is the forward button. What does this do? Current n, max n, next n. art cursor next, and yeah, okay, whatever. I mean, this is probably a little bit more complicated than it needs to be, but also the place where the only place where we actually change the history is in Chen art. Ah, yeah, okay. So make a new art by making some data structure with random shapes, which is by the way a pure function, so I can just call it and get pure mutable plain data. Can try it out. Then say a new history conch and make a new cursor as well. That is so the one minus the new history. Okay. And then make a new and then here's the also this this function is pure function, and this function is used in a swap here on this button. So it's basically handing this pure function to this swap method, and this is basically the one place where time then moves forward. That's what is happening. And the history is so easy. The history is so easy because we simply append a new art to the existing immutable data structure that is sort of this evolving history there. You don't usually you don't keep around like a history of everything that happened or something like that. That's kind of a, but yeah, if you want to do something like undo or something like, then yeah, maybe this would be one option. Another option for undo is to have command lists of things or something. Yeah, I leave this now. I hope you also saw just a tiny little bit of how you type around in Clojure, maybe, just to whet the appetite. Maybe, hopefully, maybe there's one person out there that watches Primagen and watches this and goes like, "Ah, actually looks interesting." I don't know.